Chuck mentioned during the break, Scott talked me out of C++, and then Brian talked me out of D. What's left out there?
We need to fix it while we can.
Let's fix it while we can. Speaking of which, let me introduce DiceBot to you. His actual name is Mihails. I don't know how to pronounce it.
That's fine.
That would work. All right, take it away.
Okay, so yet another metaprogramming talk is about to begin. Short introduction. My name is Mihails Strasuns. I'm one of software developers at Semantic Labs, the company my colleague Don Claxton has presented so nicely earlier today. And I must admit, the topic I want to talk about won't be really anything about what I do at my job. I'm also somewhat known for some of you as DiceBot in the community, like doing a few things here, some things there, sticking my nose everywhere generally. And I'm not actually going to talk about what I did also. Instead, I want to talk about several things I have been actually observing during last probably year or two. And my ideas, where does it lead us, all kind of ideas about projects and techniques other people use. It's somewhat funny that initially, when I had just planned for my talk and kind of looked at the published schedule for other talks, I was kind of somewhat worried because, oh, it looks like there are several other talks that can mention the same things that I want to mention. I was terribly naive. I had no idea how much the several actually is. Because what I mean, just how many talks we had during those 3 days who didn't mention the string mixins at least once. And that's what makes me feel somewhat awkward, because probably a lot of things I'm going to say have been already told. But at the same time, it makes me feel very happy and excited, because it actually proves one of the points I'm going to make. And the point is, various metaprogramming techniques, they grow out of the arcane voodoo magic state they kind of traditionally have been when started in C++, and probably have been considered as such for some time in D. And right now it's becoming something that just everyone casually uses. It's just like, you want to get job done, why not use some templates or mixins or whatever. And specifically, I believe that it's time where just those features are starting to define some distinct approach to designing programs. It's not just like a tool that you use sometimes, but some paradigm that like stands as a basis for the way you design programs. And no one has really invented it, it just like went that way. So, what do I mean when I actually like speak about declarative programming in D? It's quite a big term, and probably it's not fully applicable here. Just like I had difficulties picking a title which would really fit what I'm going to talk about. So I kind of thought a bit and stumbled upon that code in Wikipedia about declarative paradigm, and I think that sums up pretty nicely of what I consider important about kind of all those techniques and projects that I'm going to mention. So kind of declarative approach is style of building computer programs that expresses the logic of computation without describing the control flow. It's a somewhat formal thing. I'd like probably rephrase it in like in very informal way as a style that makes you separate, like completely separate, interesting part of your code from not so interesting part of your code. The point is, like, why control flow is bad? Well, it is not probably that bad on its own, kind of course you need it, but the problem is all about maintenance. The more boilerplate you have, the more control flow you have, the harder it becomes to reason about the program for you, for like any other programmers on your team. It becomes like harder to make a very quick overview of what this model does, what this program does. Just like probably everyone had this feeling when you just like come to a new project, you need to quickly investigate. You're just looking at the source code among all those like loops, conditions, and so on, and just trying to like figure out, okay, now I need to just understand what this essentially does. And one important benefit of trying to do more declarative things, as far as I believe, is exactly that it keeps the most interesting information about a program or about like a certain library completely separate from information that just needed to get stuff working, but doesn't really change depending on some sort of domain information and so on. So kind of when people speak about declarative programming, most often like languages like Prolog or pure functional languages get mentioned because kind of this is where like this paradigm has been naturally developed. And of course, D can't be like purely declaratives, because despite the fact that D is multi-paradigm language, like his base is still C domain, like C-style code, which is naturally imperative. You can do a lot of like multi-paradigm stuff on top, but essentially there still will be some imperative code. However, we have all this kind of like code generation, metaprogramming, all the cool stuff that allows us to kind of hide away all the boilerplate, all the boring details, and get effectively the same result. So kind of, and the kind of key reason why anyone would like to do that, like Attila during day one has named one reason, being lazy, which is awesome if you're a programmer, and kind of, but another reason I'm really kind of going to repeat and repeat is all about maintenance. It's all about like keeping parts that make sense, that you're likely to change if something in your domain changes, separate from everything else, keeping those easy to understand to others, and so on. So, but okay, before I proceed to an example of real projects, I guess I need to make a short overview of toolset. We have an D that actually facilitates usage of such things. And guess what? String mixins. So those who received a certain amount of bashing during first days, so and kind of people have complained about the very same things I was going to complain. Then I thought that I probably should defend those, but well, Walter has already done that today too. So by now, kind of what I want to tell about kind of string mixins, as we have those, is that, okay, they have some issues, and kind of I want to reject those, I have those issues myself, but what is the most important, it's a very simple tool that gets the job done. And that's something very definitive for D. And kind of it's probably most important tool for the paradigm I'm going to speak about, because once you're going to do like any large-scale code generation rampage, you really need some way to inject completely random code inside your program, and like string mixins are there to help. And of course, mixins would not have been as useful without CTF. And one thing that I see often kind of sometimes kind of like when D gets discussed in other languages, in other communities, and like CTF gets discussed too, it's often gets a bit underestimated in the sense that it's just, okay, just another tool to just evaluate stuff during compile time. Okay, you kind of do that using template algorithms too, and so on. However, what is absolutely critical and, well, awesome with the CTF as we have it is how natural it is to just use all the stuff you already have in your normal code, in your standard library, and so on. And for me, when kind of a few years ago, I just started to experiment with all those things, it has made like the whole world of difference between, okay, I probably have some ideas how I want to experiment, but it's probably too much of a hassle, so I don't bother and won't waste time on it. And the actual thing that has happened, okay, so generating this code is just so easy, so there is no reason for me to not to do it and to not continue with it, and so I have continued. Also, this snippet, by the way, kind of now that all such kind of approaches, code generation, get popular, one like certain idiom I want to share and popularize a bit is that approach of using string format together with token strings to get code generating functions a bit more maintainable. Because like people who just start to use it often resort to just using string literals, concatenation, and so on. And once you have quite a lot of such code, it quickly becomes not so readable. And here's an example, kind of because of token strings get highlighted by editors and development environments as a code despite being strings. And by using format, you can get rid of all the like noise of concatenation operators. You can get reasonably readable, maintainable code, and so on. Anyway, to actual example. So I decided to start with domain-specific languages as the kind of like very example of declarative paradigm, because that's something we have like in many languages, that's very common, it's widely used. So, and because of that, it becomes really clear what kind of like idea is behind this approach, why it's useful. So here I'm going to use the Pegget. I don't know how to pronounce it correctly. Sorry, it's written by Philip Segaud. A very cool library which allows to define parsing expression grammars and build parsers actually from those descriptions at compile time. It is somewhat famous, but I think not as famous as it should have been. This is like a very short example of how you actually define the grammar using Pegget. It's taken from the actual README for the project. And what I was kind of going to pay attention here is that, okay, we have this is essentially a whole program we have here. Just a few lines of code that completely define the grammar, like in the very same way you would have used it to probably describe the very same grammar to a fellow software engineer communicating it. So there is no extra information, no noise, no boilerplate. It's just like the very information you want to know about this grammar, how it works. And kind of there is no redundancy. You write there only actual things you need. And this stuff actually expands to more than 1,000 lines of code you probably don't want to write by hand. Of course, if one writes completely like manual parser by hand, actual size of code would have been much smaller because kind of there's a lot of stuff coming from just generosity. But it still would have been much longer than just this simple description, and kind of again, there is a notion of maintenance. It's not probably as difficult to write a parser for certain grammar. I'm pretty sure that anyone, like at least somewhat experienced with it, will do it easily and reasonably quickly. Well, as far as I know, for example, this is what Walter advocates to do. And that's true. However, where such like more declarative approach really shines in defining like those grammars is when you actually need to change something in that grammar later. You're going to update it, or probably you need kind of someone else who hasn't written it, wants to just come and get a quick overview of actual grammar. I guess that's, for example, something Brian had issues with regarding the grammar, which kind of we have parser for, which kind of works, but it's hard to see what kind of grammar it actually implements, and not just pretend to implement, but actually implements, and other than just on trial and error. And this is what kind of fixes it. So just kind of by keeping everything together, and yeah, kind of you have all of the same stuff, so kind of like all the imperative decode that's needed to kind of like maintain this stuff, it's still there, it's still be generated, but it's not kind of code you usually want to look at once it kind of like written, tested, verified to work. It doesn't define anything interesting about your program. This stuff actually does. So kind of the actual benefits, I have mostly mentioned those. Another thing which is really cool about using such like compiled and declarative approach is essentially the same benefit as Dmitry has mentioned during his regular expression model talk, is that how just by like moving all the information about regular expression to compile time, he was able to achieve great performance improvements without any crazy optimizations or like big amount of time spent, just because you have all information in the compile time, so it's available to compiler. And compilers these days are pretty good at optimizing things. So just by making everything available to compiler to reason about, you save yourself a lot of time from like optimizing stuff manually. However, of course, there are issues, and some of them are not pretty at all, and those have been mentioned. Of course, like CTF performance, this is probably most annoying stuff that everyone has been talking about. It's not about like performance itself, but the memory consumption and the fact that once your like grammar or any sort of like generation algorithm gets really big, so that TMD starts swapping, it gets impossible to actually get your program to compile. So, and for stuff like Pegit, for example, it's really a problem because kind of there is, for example, one guy, D-Community, Etienne, who has used Pegit to write a parser for ASN.1 grammar to actually like implement ASN.1 support in D. And he has mentioned to me that he was forced to actually do two-step compilation, like first generate the grammar, then like save it to file, terminate the compiler, let it kind of release all the stuff, and then kind of in the second step actually like compile the stuff. Because otherwise it just died from the out of memory issues and so on. And kind of being forced to do so really kind of kills the point of keeping all this stuff in line just in your D source code. So I think it is really one of biggest blockers at kind of promoting such approaches like for production, for industrial usage, because okay, once your like grammars are reasonably small, once you just experiment with those, it's all right. But real kind of big things are going to take really a lot of resources, and this is where it becomes not so pretty. Second thing is that everyone who does all this sort of kind of domain-specific languages stuff essentially does everything from the very beginning, like all the parsing, all the kind of code generation concepts. That doesn't really sound right for something that gets used so often and something that should be popularized. And one thing, for example, I don't know, has not been done yet, is why like Pegit itself is still not included into Phobos into some way. Because like Pegit itself, one of the many cool things about it is actually able not only to generate parser during compile time, but actually to parse stuff with that parser during compile time too. So you're able to use Pegit DSL to parse your DSL to generate code. I guess someone had a nice image which kind of sums it up about compiler in compiler in compiler. That's the reality. That would have made things really much more convenient, just being able to quickly define your own DSL, quickly parse it, kind of visit, and generate some code out of it, and so on. That's something probably that can be worked on without no changes in compiler, so on. That's pure community effort to do. And third problem I see in like traditional, like just plain DSL approach, that's probably can't be fixed that easy, is that there is no easy way to reflect upon the grammar. I mean, you can possibly just like save the string that defines the grammar and like parse it again, or you probably can have a look at actual structures and types generated and try reflection upon those, but that's not straightforward, that's not obvious to like user, that's not something I'd like to recommend. So, but kind of the core ideas hold, and I want to proceed like to next example, but for that, of course, we need to extend actual toolset quite a bit. So, of course, kind of, if you need some reflection in the traits, it was also kind of discussed. Nothing surprising here, just we have stuff in D, we want to reason about it, try to make it possible. User-defined attributes. Now, this is some really beautiful thing about D. I actually kind of, I'm very sorry, Walter. Initially, when you have like introduced user-defined attributes, I stood by opinion that it's completely useless crap, and I see no reason why we ever want to introduce it to the language. And right now, it's probably one of most like casual tools, like in my daily tool set, kind of something that I find use cases for like everywhere, and it really like enables exactly a lot of stuff. I'm speaking here like declarative stuff. So like user-defined attributes effectively allow us to add any sort of like meta information to any sort of this symbol and somehow reason about it. One thing that often confuses newcomers is that user-defined attributes in D don't actually affect symbols they attribute directly. So you can't like actually change the functional or struct by like attaching some attribute to it. Instead, right now, how we do it is some template wrappers are written which get actual symbol, query the attributes, find those that are of interest, and do something about it. That's probably most common idiom of like building something of top attributes. Now, kind of many people, especially kind of newcomers, consider that this is a deficiency, and we should actually make it possible to change stuff by attributes and so on. I don't believe it. I think it's actually a feature. The thing is, once symbol is changed, it is changed. So once you have attached attribute to it, you essentially like couple it with one specific expansion, like one specific code generation you can achieve from that symbol. And by like keeping the two stages, like annotating information and actual like interpretation of that information separate, you can achieve much more flexible frameworks, like interpret the stuff differently in different contexts and enable more powerful patterns. But I'll get to that later. So that's actually something I did contribute to. So an exception of general observer pattern, the vibe.d framework that has also been recently explained is, well, a relatively popular D web framework, which takes care, well, of many stuff like asynchronous input-output and the networking and concurrency and so on. Here, thing which is of most interest is its REST model, which is used for automatic generation of like all the handlers, all the routines from usually the interfaces. So kind of, this is a very simple example how you can use it. You just like have a normal D interface, no special, like no obvious code to handle actual networking, and then you just say, I want to register that interface, like implementation of that interface as a REST implementation, and vibe.d does everything for you. It figures out that this interface has that many methods, that these methods have names that adhere to like certain convention, that those take certain parameters, return certain values, and it takes care of everything. It registers roads kind of in the application. It takes care of serializing the arguments. It takes care of propagating any sort of like exceptions and kind of wrapping it up the line. And at first glance, it may look like there is not much in common between like first example, like a DSL one, and this one. However, the essential thing stays same. It's still completely different, but the very idea is that, okay, here is some really useful thing, useful information I want to know about my application. I want to show it to everyone. So here it is like public API, like the thing that gets exposed, and I want to keep it separate. I want to make it possible to users of the code, like users of the application, to quickly reason about it, to just have a look at a single model and immediately know, okay, so once this program runs, I will be able to send like requests to those URLs, kind of those will have like certain signatures and so on, and that's kind of very tightly located in one spot. And you also kind of don't need to bother about like keeping your program like synchronized to kind of get all those methods, all those like URLs and standardization like in sync everywhere, because it all comes from a single place. You just define it, and the rest of the program gets generated from it because, well, there is no reason to not to do it. It's always stay the same. It's kind of like the very concept of code reusage. And yeah, this is kind of a bit more advanced stuff you can actually do with it. So, for example, the D allows kind of the metaprogramming kind of reflection D has allows to define like some custom URLs, and from certain patterns in those custom URLs to actually infer that parameters, arguments of your API methods should be parsed from the actual URL and not like from the data in the request body and so on. That's kind of the first example. Also, you can, of course, override any sort of convention. And second example is probably the most beautiful about what's currently we have in Vibe REST. I think probably that even some of more experienced users are not aware that you can do such things with user-defined attributes. It definitely didn't come to my mind that it is possible to do that until we had a problem. But, well, it is actually possible. So the problem was that we have all that nice REST interface, which automatically does kind of all the parameter serialization, deserialization, like gets all this stuff done. But now sometimes to actually like process the request, we need some additional information that can only be got from request headers, cookies, or just plain headers. And we don't actually have place in the interface itself to provide that information because all actual arguments to interfaces are things that you expect to be provided by the caller. However, what we can do and what was actually done, and kind of initially I thought something like, oh crap, looks like that's the limit we have found for this whole approach. It doesn't work that well once you need kind of more complicated handling. But then it looks like everything is actually possible. You can not only attribute functions with data, you can attribute functions with other functions. And so in this specific example, we provide a special before attribute, which references a function alias and says that, okay, before you call this REST API method, you should actually call authorize function first, which will get all the needed request and response data, and let it evaluate one of parameters that actual API function expects. And then this parameter won't be like deserialized in a normal way. And this is getting back to initial concept, why it is actually good that we have attributes that don't modify symbols themselves. VibeD doesn't only provide tools to register routes for like a server service from your REST interface. It also provides the very same tools to get a client that will operate with the very same interface. And using this client will effectively look somewhat similar to using remote procedure calling over HTTP, with the great benefit that the fact you have just used the very same model file that defines this interface, that's kind of just the very same type, the very same entity. It was just interpreted in a, like an information attached there was simply interpreted in different ways from like different contexts. It allows you to be absolutely sure that your client and your server are always use the same API There is no mismatch because, well, it's generated from the same thing. And kind of if attributes actually modified symbols, then doing something like that would have been much more complicated because you needed to have two interfaces and modify them in a different way. So, kind of summary of the idea is that still kind of maintenance is the key. The fact that we try to remove all the code that doesn't provide any useful information means that anytime we want to change anything about our API, about the way requests are handled, we don't need to look in like a dozen different places in our code. We don't need to actually care about control flow. Just need to adjust like few simple annotations, few simple signatures, and that's it. Kind of the less changes you make in kind of fewer places, less chance of introducing the bugs is. So it also makes possible to like provide synchronization guarantees between different parts of application or even different applications, how previous slide shows, simply because you don't write the same stuff in different places. You put all your information in a single place and then you just reflect upon it. So any sort of missynchronization is just not possible by the very design. And what's also beneficial, but what wasn't immediately obvious, is that the fact that actual implementation of the class stays a normal D implementation. It's just normal D class. It is not modified to like embed any sort of HTTP processing and so on. It allows you to reuse that implementation for any sort of like other usages. Like typical example, if you have a like web application that wants to provide both AJAX API and kind of like a dynamic loading of information in the picture and like completely statically rendered page with the JavaScript disabled, then you can easily like just reuse the very same implementation, the very same class, just kind of register it directly via API model and like provide that API for AJAX calls. And at the very same time, you can just use that class normally as an implementation as you would have it used during your like normal rendering code flow in other parts of your program. Of course, there are issues. There are always issues. Right now, probably the biggest one, which makes really problematic doing some of more advanced tricks that involve STFE or template metaprogramming, is that kind of template bloat, is the amount of unused instances we create. That's something I will return to. And the probably more practical thing is that this is something that people do here and there without actually communicating, like without any decisions to go that way. For example, like Vibe D is not the only application that uses such techniques. There are things like Hibernated, for example, which is an object relational mapping library, which kind of like features the same techniques with similar benefits. So just like people here and there just kind of start using that stuff in the way they find fitting most. But it is not actually advertised anywhere, not promoted. We don't have like any good established practices, articles, tutorials about for people coming from other languages who don't yet realize how awesome and useful such paradigm in D can be. And so it kind of there remains certain like distance between those who just come to D and see all those projects and those who write the libraries. So kind of we use that stuff, but we don't actually popularize it. proceeding to kind of things that can possibly be done better, is that kind of this approach is not actually like limited to only things that naturally map between like D classes and some external domain and so on. This is something that can be used like in programs just in general, because this question that sometimes pops up in the Learn news group is that, okay, kind of, so all this cool magic, does it actually apply only to like library writers, or do I have something useful from it in my like just applications and so on? And you can actually do that, because let's take again the very same WebD example. Right now, you add new HTTP routes in WebD by just like calling methods of the router object. And well, that works, that's reasonably simple, but one alternative that could have been used, something, this is not, of course, implemented right now, that's just my speculations, that instead you could just like define all those routes as separate data structures, define at compile time, and later register all at once. And why it's useful for something like that, for example, just by having all the information about like higher domain of your application available at compile time, you can do certain like sanity checks, certain like high-level reflection. So here it's very like invented code. It's, of course, there is never something like that in practice, but you can effectively like do something like high-level test coverage for integration tests for APIs the very same way we do it like for just a plain code coverage, just by the fact that external program is able to reason about what routes, like what API endpoints this tested application actually has. So more synchronization guarantees between different parts of your code, kind of more synchronization guarantees, more compile time errors, and less runtime crap. Another thing in the realm of speculations is related to abstract syntax tree stuff. So there was like that interesting proposal by Jacob Karlbog regarding AST macros. And unfortunately, kind of the whole discussion about like actual macros has overshadowed another related thing, which doesn't kind of effectively imply macros as another thing, was directly related, is that it is useful to have some sort of statement or expression reflection the very same way we have it right now for declarations. That would allow, like in previous example, that would allow to avoid all this kind of like artificial like route declaration as a template argument list, and instead just like reflect upon the function that calls all those routes and get the same information from there. It would also allow to implement some really interesting like library features that are simply not possible right now. For example, like enforcement and assert function that actually like pretty formats the failed statement, something that is really often requested by those who got used to it in like more dynamic scripting languages. Like example nearby, but kind of that's just imaginary syntax I had in mind. And this slide is actually obsolete probably by now. And this is something I absolutely laugh about being here at DConf. Like, after the talk that Michael gave about all the kind of microcontrollers and stuff, it has inspired a short discussion between me and Martin Nowak about how we actually can make GC sections flag for LD to work. And that kills many of points I was about to make with this slide. So a bit awkward. But anyway, original problem was all about kind of like template bloat thing. Our compilers are good, are really good. They're capable of inlining stuff completely. So when you do all this kind of like code generation and like complicated like template helpers and so on, actually when you have some compiler like LDC, actual generated code is really good. Like no those temporaries, no those templates, weird wrappers actually get called there. But all this stuff still gets placed into binary. And this is really a problem, especially like for something like VibeD, which is supposed to be performant server. Because, okay, this stuff is never used, but it still takes place in the binary. And this can really harm the instruction cache, because simply actual functions that get used are located far away from each other. They're not like one straight next to each other. And that makes really desirable to have like some tools to eliminate all this stuff that you're absolutely sure should not be in resulting binary. So kind of like my original proposal was to introduce some sort of like no code generation attribute that will clearly say to compiler, this symbol should not be in binary. You can even not bother emitting it into object file, just pure compile time entity. It's a hacky solution, which I wasn't really kind of that happy about, but it seems like a good idea because doing this in the right way, using some sort of like link time optimization or like whole program optimization, didn't seem like something we can do in any reasonable time. So, and some solution that can be used right now was really useful. But right now, with kind of all that recent discussions we had here at DConf and new information, probably it is actually possible. So this proposal, not that useful anymore. But if stuff with GC sections is not going to work, probably we can return to something like that. So, short summary of what all this stuff was about is that declarative programming in D is some like imaginary paradigm that it is not directly supported, like in a very straightforward way, but that's something you can make to work by simply organizing your program in a different way, and something that helps maintenance of your code really a lot. So say, especially like if your programming team is big, a lot of people working on the same code that are not really aware of all the details other people do, just having compile time verifications of kind of internal sanity of your application is very useful, and we can do quite a lot of cool things with it. The best thing that probably can be done with it is to try it a bit more and come to some specific patterns, how it actually can be used, some design guidelines for like less experienced users, and then we probably can start promoting D not as only having a good like functional generic paradigm and object-oriented and whatever, but also having a decent support for declarative approach.
Thanks. Let's give the man a hand. Oh, that doesn't bode well.
Can you go back to that slide you had in the UDA toolset? It's one of the early ones. Yeah, there you go.
Which, this or next?
Yeah. No, after that.
Okay.
There you go. In that static if, you might know this already, but just in case for people watching there. In that static if, you're testing to see if the type of UDA is call-in times. Now, that's going to work if all
if
of your attributes are values. If any of them happen to be a type, that's not even going to compile.
Yeah. That's the problem, actually, with preparing examples with like so heavy metaprogramming stuff, is that trying to produce a real example that works everywhere is likely to take like a lot of 10 slides to actually produce just like a single function that works correctly. And kind of this is actually the reason why I believe we need to really add more of such stuff into Phobos, because it's really not obvious. Like, there are a lot of reusable things that are totally not obvious to write at the very first time. And currently we miss them. I have some of such utils, for example, in vibe.d internal package. We should consider moving more of that stuff into Phobos.
I figured you knew. I just wanted to make sure that for anybody watching, if you try this at home, it might fail.
Okay, yeah. Yeah, there are some examples that you shouldn't try at home. For example, that authentication function is also something you shouldn't try at home. Yeah, this one. Don't do that, please, ever.
Actually, that's what I want to talk about. Can you go back to it? Because basically, right now, you're putting the before in the interface, right? So you don't put it, you put the before on the interface. So you can't use it on both sides because as it's in the interface, you need the authorize in the client as well.
Well, it needs to be somehow imported from the file where it is declared, but well, that's only requirement, I presume.
Because actually, I tried it in one of my projects. And what I tried to do is provide a context to a function, so do authentication. And I realized I couldn't use it because I was doing some, I was requesting my server, some SQL stuff inside the before handler, and I didn't find any way to add it from the client, so I had to keep two separate interfaces, one for the server and one for the client.
Interesting. I guess that's something we're better to talk about like later, just probably that will result in a bug report I need to fix, so I guess that's more of a design problem than just a quick question.
Questions? Got a couple of minutes for questions? All right, there's a couple online. When will static for each be available?
Well, that's not a question to me. Actually, I guess that's more something to ask compiler developers. I'm not even the author of actual static for each proposal.
So Walter has had to leave because he had a flight and Friday long weekend traffic to battle. So anyone can answer the question?
But I fully agree that static for each is something that will reduce the complexity of some of my code really a lot.
Okay, terrific. Martin.
I only have a very small comment. Like Walter mentioned yesterday or the day before, that there were a few reservations towards the dip, which kindly introduced static for each or something. So I don't know much more, but there's
I haven't seen much action about it, but I'm eagerly awaiting it.
So we need to resolve the whatever.
Okay, I don't recall him commenting about it into that like deep review thread, so probably he should actually tell us about what problems are.
Right, I think we've talked a fair amount about that, and essentially the matter is binding the name to different things in turn in the same scope. That's sort of the problem. But the fact that you would find it highly useful for the kind of stuff you do, which is pretty awesome, is is a good
Because kind of right now, pretty much like only alternative to static for each is to use like recursive template implementation that will like consequently inject like mixing stuff into scope more and more by calling itself. But that again, like template bloat that will recursively generate the amount of like template instantiations equal to amount of like parameters to for each, which is not really good. So yeah.
Okay. Put your hands together for DiceBot. Thank you. Five minutes.